Hello, my name is Tyler. I'm a professor of medicine in the Department of Medicine and Medical Oncology at the UT Health Science Center in San Antonio. And I'm an immunologist by training. I'm a medical oncologist professionally as well. And I just love my job. I have a research lab that's NIH funded, and I have technicians, students, and postdocs. And the most fun thing for me is I essentially get to play in my lab all day with big, expensive equipment and find out things that nobody's known before. And we hope that what we find isn't just fun, but it's also useful and important and helping change the way that we treat disease, particularly cancer. So in my first career, I did infectious disease immunology, and I worked with Chip Schooley and Bruce Walker at the Mass General Hospital at Harvard Medical School. And in the lab, I learned how to use viral vectors to make antigen-presenting cells so I could watch people with AIDS virus infection and I could monitor their immune responses. So I didn't develop any of those techniques, but I made some minor tweaks to it. And then I went on from there to do the opportunistic infections of HIV infection. And I worked in a setting where we were growing toxoplasma, which is an intracellular parasite. And in those days, before the really good anti-AIDS medicines, toxoplasma infection was a really big problem. So I invented a number of methods that we could use to monitor immune responses to toxoplasma in humans. And I think that's the first major contribution in terms of technology that I made. Over the years, I had a really stellar postdoctoral student, Wei-Ping Zhu, who's gone on now to become a very prominent, important immunologist at University of Michigan. And with Wei-Ping, we started figuring out how to do this in cancer, and we were learning how to take immune cells from patients with ovarian cancer and then developing techniques so we could monitor the human immune response by partially humanizing mice, giving them partial human immune systems, putting the tumor cells in, and then altering things to see how immune cells could either kill cancer or be prevented from killing cancer. This year is actually a banner year. We submitted 7 papers this year. 6 were picked for oral presentations, and I'm chairing the block symposium on tumor immunotherapy. So part of my job is to train the next generation, and I really enjoy training students. I typically have 3 to 5 graduate students, 1 to 3 postdocs in my lab at any one time. And one of the biggest kicks I get these days is my trainees are up on the podium giving the talks, and it's their hard work. Some of it's my ideas, and together we're doing more science and telling the rest of the world what we're doing, and the trainees are doing incredibly well, and I'm watching them evolve and become their own independent scientists. A major success story in mentoring is Wei-Ping Zhu came to my lab doing his second postdoc, having done his first postdoc in France. And when he joined, I initially asked him to look at some aspects of chemokine signaling. And then around this time, we decided to look at dendritic cells in cancer because there wasn't a lot known when he joined the lab. We quickly developed a project. I gave him a couple of suggestions. And then within about 6 months, he was in the office drawing pictures on my board and then telling me what he wanted to do and how he thought things ought to go. And I thought, wow, this guy learns really fast. So it was very gratifying to watch how quickly he developed. I'd like to take a little credit, but largely he's just a very smart guy, very driven, and just need to be turned loose with the right set of tools. And he's done incredibly well. He's now Director of Translational Sciences, Professor of Medicine. He has an endowed chair at University of Michigan, and is very well known and doing extremely well. The most important thing about immunology is it's not just a defense against insults. It's a homeostatic system that tunes many processes in your body, and we're still not fully aware of all the aspects of it, but it controls metabolism. It works in concert with the microbiome in your gut. It's a two-way street there. And it also, incidentally, protects against infections, cancers, and autoimmune disease. So I've been coming to the meetings for over 20 years. It's always been a positive experience. I always like coming to AAI, seeing my colleagues, watching new developments. Over the years, there's been an emphasis on mentoring, which is new compared to when I first started coming. There's programs on grantsmanship, how to find grants, how to write your grants, how to get them funded, manuscript publications, symposia for how to be a section editor for the Journal of Immunology or other journals, because you're not born knowing how to edit scientific journals or write them. So they're trying to help people acquire the skills. The mentoring is very important. GRIP is a specific program of research mentoring for immunologists that AAI has sponsored, and I'm a GRIP mentor. And they've evolved over the years with the way the field has evolved. So even 5 years ago, tumor immunology, immunotherapy was the backwater, just 5 years ago. And now it's at the very forefront. There's a large number of tumor immunology sessions. There's new sessions on technology. And over time, I think AAI will continue to be at the forefront of helping people understand the new technologies, funding opportunities, and so on. When I'm talking to medical students, I tell them with a straight face, everything is really immunology, everything. And I dare you to name a disease process that isn't immunologically related. And that's a little hyperbolic, but it gets them thinking, and it challenges me sometimes when they come up with diseases. I have a hard time pigeonholing it into some immunology cubbyhole. But we now recognize that immunology really is critical, not just to protection from pathogens, but protection from cancer. And there's a revolution going on in immuno-oncology where we can think about really using immunity to treat cancer, to fend off metastatic disease. 5 years ago, that was just about unthinkable. We're seeing the interface between immunology and metabolic processes, between immunology and the microbiome. And I'm sure there's going to be more surprises in the future, things that we're not fully aware of now that'll be pivotal. But I'm very happy that I ended up staying in immunology and that I took the chance as a medical student. I think it's one of the foundational disciplines.